Welcome to Science Corner Tutorials. We'll be looking at science concepts in depth. Get ready. Let's get started. Today we are moving on to the next topic that we want to look at. So I'm so excited to introduce you guys to this topic. It's one of the topics that most students find to be challenging, but I'll try and simplify it, for you guys so that you can master the concepts and you'll be able to solve any problem that will come your way as far as differentiation is concerned. So, what I want you guys to do is to take your time, right? Is to take your time first of all. This is supposed to be take your time. Take your time first of all to understand the basic concepts, right? Take your time to understand the basic concepts, and from there you'll be able to solve any problem that will be given to you. So when solving the differentiation problems, I'm going to divide different concepts into different lecture series. So this is the first part. Then we're going to have a subsequent lectures whereby we'll be looking at different concepts, and we'll be giving you then um, problems where you need to apply, two or three concepts at the same time. So for the meantime, we're just applying one concept at a time, and you make sure that you understand it as we are starting. So when asked to differentiate, right, when asked to differentiate y with respect to x, right, this can be written as dy over dx. So this is what I've written here. This can be written as dy over dx. So this statement that is saying differentiate y with respect to x is similar to dy over dx. So when asked to differentiate x with respect to y, you can write it as dx over dy, right? So the one that is being said with respect to becomes your denominator, right? And the one that is you're asked to say differentiate this part is the one that becomes the numerator, right? So make sure that you understand this very simple concept here. Then from there, the first concept that I want you guys to understand is that when you are given any function of the form x to the power of n, right? Like right here. The derivative of x to the power of n, any function of this form, you find it by saying d of x to the power of n over dx. And when solving this, you take down your power here, which is n. So you're going to get n, you've taken it down, right, in bracket x. Then you're going to substitute 1, right, from your power n minus 1. So this is how you are going to get the derivative of any function of the form x to the power of n. So this is what I've done here, right? When I said if you're asked to differentiate y or x to the power of n, the derivative of that is n in bracket x to the power of n minus 1. So the first thing you do is that you take down your power here, which is n, right? Which is n. Then you're supposed to subtract 1 from the power as well, which is n minus 1. So let's get this concept right. So for example, if you want to apply this concept, so you're asked to say, okay, fine, differentiate y equal to x squared. That's the equation, that's the problem that you have. So it means that your dy, right, over dx is going to be 2. You've taken down n here, right? N equal to 2 in this case. X the power of 2 minus 1, which is going to be 2 of x to the power of 1, right? So finally, you're going to get 2x as your final answer, right? I'm sure you guys, you're understanding this basic concept, right? Then I've got another example, right? that we have to make sure that we understand this simple concept, right? And the example is saying differentiate y equal to, which is the second example here, x the power of 3 plus x the power of 4. So our dy over dx equal to, you take down your n, in this case n equal to 3, so it's 3x the power of 3 minus 1, plus you take down your n here, it's 4x the power of 4 minus 1. So you're going to get 3 the power of x 3 times x the power of 2 plus 4 times x the power of 3 is your final answer. So make sure that you understand this first concept, right? Any function of the form x the power of n here. Then moving on now to the second concept, the derivative of a constant, right? The derivative of any constant is always equal to 0. So when you're asked to differentiate, for example, y equal to 2, as in our example here, so your dy over dx, you get 0, right? So when combining the first concept now with the second concept, right? Let's say you're asked to differentiate y, right? You're asked to differentiate y equal to x squared plus 5, right? So your dy over dx, you get 2 the power of x, 2 minus 1, plus the differential, the derivative of 5 is equal to 0, right? So it means that your final answer will be 2 to the power of x, right? So make sure that you understand this second concept as well. Moving on now to the third concept. So any function of the form, um, any function, right? Any function of the form um, a the power of x, ax, sorry, plus b, all this being raised to the power of n, is derivative, which means that d of ax plus b the power of n over dx, you find it by bringing down your n here, bracket ax plus b the power of n, right, minus 1, right? Then you multiply all this by a, which is the coefficient of x here. This is what we've done here. Any function of the form ax plus b the power of n, its derivative is found as d ax plus b, right, the power of n over dx is equal to n. You bring down your power n here, right? Then after bringing down your power, you then subtract 1 from the power. Then you take the derivative of x. You multiply everything by it, right? Make sure that, guys, you understand this. I know it can be, a bit, challenging, but make sure that you understand this simple concept. So let's put this into practice, right? So that you can understand this better. So, for example, you're asked to differentiate y equal to 2x plus 5, the power of 6. So it means that your dy over dx equal to 6, right? Taking down your n, 2x plus 5, then 6 minus 1. Then you multiply everything, right? Then you multiply everything here. Then you multiply everything by, want to multiply everything by 2, which is the coefficient of x here. So you're finally going to get 6, right? 2x plus 5, the power of 5 times 2. And your final answer will be 12. 2x plus 5, the power of 5. So make sure that you understand this basic concept, right? So let's work out another example. So let's say you're asked to differentiate y equal to x the power of 5 plus x the power of 2 over x. So before you differentiate this one, make sure that you have simplified your equation because this is not simplified, right? So how do you simplify? You can factor out. You've got a common, if you factor out x on the numerator, you can get x to the power of 4 plus x all over x. And this x here and x here can cancel out. So your final, question will be x to the power of 4 plus x, right? Now, when you're now differentiating this, right, it means that you're going to get dy over dx, right, which is equal to x. 4, you bring down your n, 3 minus 1 plus 1, which is the n of this x here, x to the power of 1 minus 1. So you're going to get 4x to the power of, it's 4, sorry, 4 minus 1, the power of 3, plus any number to the power of 0 equal to 1. So this is will be your final answer here. So as your homework, you guys, as your homework, I want you to try and work out. I want you to try and work out this simple problem here. It's saying differentiate. The first one is saying y equal to x to the power of 3 plus 4. Then the second equation is saying y equal to 2x plus 3. All this being raised to the power of 4. So make sure that you post your answers in the comment section. And when you find problems, you're going to go through them together. Right. So this is the first part of differentiation, guys. Make sure that you understand these three basic concepts that we've introduced, right, before we move on to the next part. Thank you.